Hello, everybody, and welcome to Discussions in Orbit, REXUS BEXUS Edition, our series of live interviews organized by Team DROPSTAR. If you're familiar with DROPSTAR, you know that our team participates in the REXUS BEXUS Programme, a German-Swedish student program where teams from all over Europe are selected to design, build, and execute an experiment in one of the two available platforms, BEXUS, which is a stratospheric balloon, or REXUS, which is a single-stage rocket. In Discussions in Orbit, REXUS BEXUS Edition, we interview fellow REXUS BEXUS teams in order for them to introduce their experiments to the public and share their experience in the program. So, today's team is SHEAR.
Team SHEAR is building an experiment that aims to test a self-developed heat shield material. This new material is an alginate and montmorillonite nanocomposite foam. The experiment consists of 5 heat shield samples, which will be placed, 3 of them in one of the rocket's module and 2 of them in the rocket's nose cone. Each heat shield will be instrumented with 3 thermocouples to measure the temperature of the samples, as well as the heat gradient across them. The data will be compared with on-ground tests and simulations after the flight. So let's now meet the team behind the experiment. Team SHEAR, welcome to Discussions in Orbit, and please introduce yourselves to the public.
Hi, it's very nice to be here. My name is Lawrence Feiten. I'm a master's student in spaceflight dynamics. As a fun fact about myself, I used to like planes. I know, L.
Hello, thank you for having me. My name is Oliver Ross. I am a master's student in spaceflight engineering at the TU Delft. Fun fact about me, I am a lacrosse player. That is what my favorite hobby is in my spare time.
My name is Christina. I'm the team leader of Team SHEAR. And originally I'm from Serbia, but now I live in the Netherlands and I study bachelor's in aerospace engineering.
Hey, I'm Jeff. I'm now doing my master's in systems and control and computer science, and I work on the electronics on the team.
Hi, my name is Isha. I am the newest member of the team, currently doing the PR and the outreach managing of Team SHEAR. And on the side, I am studying bachelor's in aerospace engineering.
Hi, I'm Niklas. I'm the mechanical guy of the team. I'm basically making sure everything fits together. I study also spaceflight engineering for my master here.
Great, so welcome once again. And in order for us to begin the interview, we would like for you to describe us the concept of your experiment.
Yeah, sure. So very short introduction to our background. We're all part of a student rocketry society that builds high altitude rockets. And when they come back, they of course re-enter the atmosphere, which means heating. In the past, rockets have used cork, but a student that's part of our group, he developed a self-developed heat shield for his master's thesis, which hasn't flown yet, but we want to make it flight ready. So that's basically the gist of our experiment. We're trying to take that developed heat shield and apply it to a rocket, and REXUS makes that possible for us.
Right. Well, I mean, it's definitely a risky, if I would say, experiment, because trying a heat shield on an application on a rocket, I don't know, it sounds like a lot of things could go wrong. So you guys need to be definitely bulletproof and definitely have done your homework. So I suspect you have quite a few members of your team out of varying expertise. So could you tell us more about your team and the members inside it?
Yeah, so we have a very diverse group of people who are in the team, mainly from a lot of different faculties from the university that we're at. So all of us are students at the Delft University of Technology in the Netherlands. And I mean, you've heard most of our names right now. 2 of us are in a different country doing their exchange. And we're from faculties from computer science, electrical engineering, aerospace engineering, systems and control. I mean, it's an entire group of people. So luckily we have a lot of skills that we can apply to this project.
Great. So it seems that you have a very strong team and, of course, a very interesting experiment. So I would like to know more about your goals. What do you want to achieve with the shade experiment?
Sure.
The shear experiment. Oh my God, I'm sorry.
Of course. So as you talked about a little bit before, our aim is to be able to characterize the thermal properties of this new heat shield material in realistic reentry conditions. Like you said before, the experiment does have some risk involved, but we want to learn more about how this heat shield performs in real life, such that we can hopefully increase the technology readiness level of the material and maybe propose it as a reliable alternative to traditional materials on different rocket missions, both in DARE or outside of DARE. So really, it's all about verification and just learning more about how this material performs overall.
Seems like a fine goal. I mean, you would imagine that you need to somehow build up to that and have a lot of on-Earth tests for something like that. Can you describe the process that finally brings you to test a material to its rocket flight? So what kind of tests have you done previously with the experiment to finally bring it to a rocket?
So to describe a little bit more about the tests, we have done a lot of different types of thermal tests inside of laboratories at the Delft University of Technology. So this includes conductivity tests, emissivity tests, and other mechanical tests, such as the strength of the material and how it bonds to the module overall. So these tests, in combination with different integration tests and electronics tests, and a much broader scope of tests outside of what I just mentioned, allowed us to get more confidence in our overall experiment, such that we feel that we can put it on the rocket and that we can get the scientific information that we're looking for.
And what are some of the main difficulties that you had to face when studying this new material?
Well, the biggest difficulty by far has been the heat shield itself. Essentially, the rest of the experiment design went quite well. You have it already on the screen, but the heat shield has been taking essentially the last 9 months of iterations to get closer and closer to something that could be on the module itself. Only recently, a few weeks ago, we started making very meaningful progress and getting something that can actually fit on the module. So it has been mostly about my team in Delft has the samples, if you can see them a bit. But it's really about having the correct mixture, the correct structure, that it doesn't break, it doesn't have too many cracks. That has been very challenging.
Well, I mean, you definitely seem more than capable of taking on that project, and after having this short conversation with you, we are quite confident in your work. So can you please describe to us what you're currently working on with the team?
Yeah, I mean, we're working on a lot of things. Everybody's working on different things. For example, I am working on a lot of ways to try and brand shear in general with some different companies in the industry, and in general, just trying to do some social media managing so that we establish ourselves to everybody and try to see whether people can get to know us a little better. Other than that, also trying to do some event hunting and general merchandise. We can also probably get you guys some merch of ours. And in general, I think, for example, Nicholas is working on finishing up some integration and final modifications of all the mechanical parts that we need to fit into our module.
Getting that absorbent material in to prevent you guys from frying our electronics and stuff like that. Always good fun.
Yeah, and from my side, I've been mostly organizing the team and managing how we're going to work towards finishing this project, as well as organizing all the integration and testing, planning around it. So yeah, it's just to make sure that everything works as smoothly as it can be. And then we also have Jeff, which is for electronics.
Yeah, so for electronics part, all of our hardware is now done. So at the moment, it's a lot about preparing all the software, finalizing all the software. This is on the side of our module, our experiments, making sure that we get all of our data correctly and it's stored correctly, but also on the launch interface side where we can actually see our data from the downlink.
Yeah, and from the other side, guys that are currently abroad or for their internship are also being still active within the team. And they can tell you a bit more about what they're doing. But most importantly is that even from a distance, they can still contribute to the project. And soon they will be back to help us in person as well.
You essentially said it indeed. We are mostly there as support in this way. For me, I've been focusing on giving my month of knowledge in terms of heat shield making to Nicholas and Jeff, who have been my hands on the ground and organizing those sessions. And for you, Oliver?
From my side, I've been helping in overseeing the tests that are being run on a component level and scaling up to subsystem and system level testing, essentially just making sure that the performance of the module complies with our requirements and our objectives, as well as complying with the constraints that are set out by the REXUS BEXUS campaign.
Okay, so in short, you are working on everything.
Yeah, you're on fire. So, I would like to take us a bit in the science of the materials. So you are working with an alginate and montmorillonite nanocomposite foam. Can you tell us more about this new material? Because I'm pretty sure it's something new for a lot of people.
Including us.
Yes.
It's a lot of difficult names to say nanoclay and alginate, which is essentially algae that was dried up. To be completely honest, in terms of understanding why the mixture works, you will need to ask the PhD who made the material, who is unfortunately not with us. But yeah, in terms of the material itself, it's a biomaterial, kind of sustainable in this way that is promising because it's so easy to manufacture. As a quantification of that, it takes 2 hours with 2 people to make one batch of like 3 or 4 samples. Just because it's about nanoclay, dried up alginate algae that you mix together, put some water and bake it, and then you have some nice samples that look like cookies. So that's what I can tell you about those samples.
Oh, they sound very attractive.
Are they edible?
Just one more thing about looking like cookies. The stuff is so sustainable, you can theoretically also even eat it. I've tried it, I don't recommend it.
Oh.
I did not expect an actual answer to that.
Yeah. Well, that's interesting. Do not try this at home.
Don't eat space cookies.
Say. Yeah.
I mean, you can.
You can, it's
but
just not very tasty.
It's not tasty. Maybe if we add some flavors to it, maybe it will be tasty then.
I'm slightly concerned.
Okay.
For Team SHEAR. Okay, so cookies that you put on the outside of a rocket is incredibly interesting. Could you tell us more about the science behind your experiment and describe shortly describe the phenomenon behind it?
It's true. I realize now that we have been speaking about a heat shield without explaining what it is. During a rocket flight, both during ascent and descent, you can go up to very high speeds. We're speaking even for suborbital flights from Mach 2 to Mach 4, which for the people who don't know what Mach is, essentially the speed of your rocket divided by the speed of sound where you are. And the higher your Mach, the higher the compressibility of the flow and also the temperature effects. The air gets really hot around you. And that can essentially damage a structure, sometimes even destroy it if it is not protected well enough against all this heat that is incoming. The heat shield, its primary goal is to absorb it and be able to radiate it away as you are flying through it, such that the structure is not taking that is not taking that load directly. So yeah, that's about it. Very high temperature effects that are absorbed by the heat shield and diverted to the outside world rather than the rocket itself.
Very interesting. Thank you for this explanation. And let's now talk about the REXUS BEXUS program, because the fact that we are having these interviews and of course we are actually building our experiments is because we are participants in the REXUS BEXUS program. So how is your experience so far in the program?
I mean, of course, the REXUS BEXUS experience has been absolutely wonderful. It's really unique to give us students also this opportunity to work with industry professionals and to see how things actually work in the industry. I myself have only relatively recently joined the team, so I haven't had as many interactions with REXUS BEXUS as much, but from the limited ones I've had a really positive experience. I mean, just from being able to learn. So within there, with the student team, we do things in a certain way, like how sometimes students burn some solutions, but within this, we really learn how to work more professionally and to a certain standard. So really learning these industry standards, and as much also in this project, we sometimes make mistakes or things don't always go the way we expect them to. And from this side, we have received a lot of technical support from ESA, different people from ESA who have really helped us a lot and also really helped us understanding the design process, the manufacturing process, also the troubleshooting process as we go about this project.
That's great. I mean, as expected, it's a very positive experience for most people to actually be part of this program, and it's a privilege, to be honest, because a lot of people would like to be in it and don't have the chance. So what advice would you give to a team or somebody entering a REXUS campaign currently?
If I was to give advice to anybody or any team that is looking to join the REXUS program, I would have two big pieces of advice. The first one would be to go for it. If you have a good idea and if you have a dedicated group of people who are all working together to achieve the same goal, then even if you're not sure about some of the smaller technicalities, you should go for it, because it gives you so many more opportunities to experience the professional working environment, to experience new facilities, to experience, ultimately a rocket launch at the end, which is what we all want to see. So go for it and give it a go. The second advice I would say is be organized and communicate all the time. Do not wait last minutes until deadlines. Make sure that you have everything planned out and organized. And if you have any questions, ask them, because there's a wide support network out there who are willing to, or who want to see you succeed. So ask them, because the earlier that you ask them, the earlier you find solutions. So those are probably the two biggest things I would tell an upcoming team about to join the program.
I'd say that's very good advice.
It was a very inspirational answer, actually. Yeah. And I would like to continue on that note and ask each of you if you could say maybe what are the main lessons that you took from the program and what will you be implementing in your future career?
Sure. Are we okay? No. The main lessons on my side, I would say it is probably the teamwork experience. Of course, during your studies, you get to work with a lot of people, But here it's the difference, like people are directly motivated to do that. It's trying to get everyone to work together, get the whole atmosphere together. I think just having the right state of mind for that to work is a big takeaway that you can have from this program. So that's probably something I will take home.
Yeah, I'd probably follow in a similar with a similar lessons as Lawrence. I probably would take away proper coordination as the biggest lesson from the experience. As a testing engineer, I have to be involved with the functionality of every different subsystem and make sure that all of them work, which means that if I want to organize a certain test, I need to be able to collaborate with everybody, both individually but also on a group scale, to make sure that things can get organized and that we can get the data and the confidence that we want. And that's something that I really had to develop over the last couple of months, or maybe even, it's been a year. So for me, it's been a year. So this is something that I've really had the opportunity to develop.
For me, I would say it's the main thing is about communication and how you deal with interfaces with other teams and also with your mentors or the coordinators for this rocket launch. Because there's always some new thing coming up where the team that's situated in the same rocket above you or below you has some new constraints or requirements on you, as well as being able to ask questions and actually doing that to your coordinators or mentors. And that way communicating with them has been really helpful in how it works in industry. So that's a big lesson I've gotten from it.
Well, I've been in the team for, I think, 6 months exactly now. And it was an entire different experience for me to get into a team who's already knowing each other and who have already been busy with this project, which is very, very amazing. So I think the biggest lesson for me was that I was able to get into the team, and immediately there was this environment of communication and teamwork, and I had to sort of develop a lot of skills which I've never experienced in my entire bachelor or my entire career, such as communication and design and in general a little bit of management, of doing a lot of things at the same time, and having to design posts and all of that. But I think one of the biggest takeaways I'll definitely have also being in SHEAR is just being in a team with all of these students at the start, but sort of like a family, friends and family basically of ours at this point. And we all know how much we're going through and how much work we're putting into it and how much effort we're putting into it. And so the biggest lesson I could learn from it would be that I would want to work in such a team again, and I would find such a team again, I guess.
Yeah, I think for me, I also really learned a lot throughout this program. But I think that the main thing that was also unique learning thing for me within this project was also joining it somewhere in the middle, where I had to sort of take over the development of an existing system, and as well the system that interacts with all these other stakeholders within the REXUS BEXUS rocket. So, mainly from the REXUS BEXUS side, different protocols and things that you have to take into account. So it's really this learning how to actually work with the unfamiliar system and how to understand the system deeply, a new system deeply enough that you're able to directly work on it. This skill is something that really taking away with this project.
And to finish it off, for me, I think from the team currently here, I think I've been in the team the longest. So I haven't been really from the beginning, but we did start the project basically from scratch. So it's been really a ride since then. And of course, it's not done yet, but we've learned so much. It's been an incredible educational experience. all the things that we did not even expect to encounter, we did, of course. You always learn the university is in most cases a lot theoretical, but when you actually put your knowledge into practice, you can see that there is a whole new area that you did not know you didn't know. So that's very valuable to learn when you do a program like this. Also, it's when you put everything together, you can see how well it works together, how it doesn't work together. And that's also something that we learned throughout this program. Also, another thing I think that it's most important here is I think what is most valuable, or like the point of aerospace in general, is to keep it simple and stupid, as they say, because the more you complicate it, the less chances it is to work. And just keeping it simple and doing something that's been tested and that's something that you know is going to work doesn't mean it's going to work, but at least you're removing a lot of problems that you can encounter from that point onwards. So just keeping it simple, and especially since we're just a student project, you really need to keep it simple to make sure you're going to get to the launch and hopefully it works. So I think that's one of the main lessons that I would take away from here.
A lot of wisdom and a lot of motivation from these members.
I enjoyed all the answers.
Yeah, very much like your answers, actually. I'm almost reluctant to go back into a technical question, but I'm also very curious.
We have to know.
Yeah, we gotta know. We want to talk about your timeline. So what will actually be happening during the rocket flight in your experiment?
To answer that question actually is quite a nice segue from what Christina just talked about keeping it simple. The most active part of our experiment is actually the electronics. The essence of our module is just that we want to measure temperature. That's its goal, and to relay it down to the ground so that we can observe the data. So essentially the timeline of our experiment is simply that prior to launch, we activate our electronics system. And from that moment onwards, our thermocouples record data from all our heat shield samples. And then those are both saved on board and also sent down to the ground. And this procedure continues essentially all the way through the launch, from launch up until touchdown, where our electronics are powered off, and that's about it. The only interesting thing to point out is that we do have samples on both the module as well as the nose cone. So at the moment that the nose cone separates, we won't be able to get temperature readings from those samples any longer. But we do hope to be able to recover the nose cone so that we can do a qualitative analysis on the samples as they re-enter. Maybe we'll be able to deduce something from the appearance. But yeah, the timeline is very simplistic. Just turn it on and turn it off and record data. That's about it.
That's a nice but effective timeline.
Yes. And we wish you that it all goes well. And that you have the most interesting observations. And it is time to wrap up the interview, unfortunately. But as it is customary, I would like to finish the interview with the question of what would be your experiment's contribution?
As we explained in the beginning, our heat shield is a new material that on the ground has shown better mechanical and thermal properties than some standard heat shield materials that have been used so far, just like cork, for example. So having a material that is better performing, much easier to manufacture and much more accessible, as well as biodegradable, so very sustainable in that sense as well, is, I think, in our case, is a material of the future. So I think it can really help with the aerospace industry becoming, on one sense, more sustainable, but on the other sense, more simpler product to be integrated as a heat shield material.
Great, guys. So thank you for being with us. Thank you for participating in discussions in orbit. And once again, we wish you all the best with your experiments, and Dimitri,
Oh yeah, I gotta say it. See you on the rocket.
see you on the rocket.
Yes, thank you very much and see you soon.
See you soon, and good luck with your experiment as well.
Yeah.
Thank you, guys.
Thank you very much. Have a good day.
Have a good day.
You too.
Bye bye.
Bye.